Okay, let's take a few minutes to review factoring. Most of you have probably already had factoring somewhere in your math education, but maybe it's been a while ago and you're a little rusty on factoring, or maybe some of you, even when you learned factoring, never quite mastered it like you need to. For this class, factoring is essential. If you're not able to factor, you're going to struggle with a lot of areas in this class. I like to teach factoring by saying there are really two questions you have to ask. And once you answer these two questions, then you should be able to factor pretty much whatever kind of expression you're given. So here are the two questions. Whenever you're given an expression and you're asked to factor, a lot of times they'll say factor completely. Or down the road, we're gonna have some equations to solve, and oftentimes we're going to use factoring to solve the equation. The two questions. The first question is there a GCF? And the GCF stands for greatest common factor. Okay, greatest common factor. And let me go ahead and give you the second question, and then we're going to spend a little bit of time and work through some problems and try and find the GCF. But after you check for the GCF, and if you have a GCF after you factor it out, then there's only one more question that is important, and this question really determines what you should do next to factor. And that question is, how many terms are there? In any expression that you're trying to factor, the number of terms will determine what you're going to try. So the number of terms is absolutely essential when you're trying to factor. If it's 2 terms, we do a certain thing. If it's 3 terms, we do something else. And if it's 4 terms, we do something else. So it's going to be one of those 3, either 2, 3, or 4 terms. And we're going to do some example problems in a few minutes of both 2 terms, 3 terms, and 4 terms. So right now, let's go ahead and look at question number 1, is there a GCF? And actually look at some examples. So say you were given this expression and you were asked to factor it completely. All right. 15x squared plus 5xy. So you have 2 terms, but I'm not really worried about the terms right now. The first question I'm going to ask is there a GCF? A GCF means you have to look at all your terms, and then you look at both the numbers and the variables. When you look at the numbers, you say, when I look at all the numbers, all the coefficients, is there a common factor? Is there a number that goes into all the coefficients? Now in this case, we have 2 terms, we have 2 coefficients, 15 and 5, and you ask yourself, is there a number that goes into 15 and also goes into 5? And hopefully realize that yes, there is. In fact, it's 5. 5 goes into 15, and 5 goes into 5. And then you look at the variables, and you see if there are any common variables in all the terms. And if you do have a common variable in all the terms, then you're going to choose for your exponent the smallest exponent in all the terms. In other words, if I look at the x's, I have x squared, and in the second term I have x. So I do have x's in both terms, but in the first term my exponent is 2, the second term my exponent 1, so you always take the smaller exponent. So now my GCF so far is 5x. 5x is common to both terms. And now I look and I see a y here in my second term, but when I go to my first term, there is no y. Therefore, y is not part of the GCF, because the GCF, the variable has to be in all the terms. So as it turns out, for this expression, the GCF is 5x. Now what we do is, we go ahead and we like to use the word, we factor out the 5x. Sometimes people say they pull out the 5x. And now we're going to create parentheses. It's almost like we're doing the opposite of the distributive property. Instead of multiplying out parentheses, we're trying to create parentheses. So here's what you do. I'm looking at this first term, 15x squared. And I say to myself, 5x times what equals 15x squared? What do I have to multiply by 5x to get 15x squared? Hopefully, most of you realize that it would be 3x. So 3x times 5x equals 15x squared. Now I bring down my plus, and now I look at the next term, 5xy, and then I say what times 5x would equal 5xy? It would be y. And then what have I done? I've factored out the 5x and left inside the parentheses is 3x plus y. If I would happen to multiply out the parentheses using the distributive property, it would equal what I started with. So I factored out the 5x, and the 5x is a GCF. Let me do another couple fairly quick examples now that I don't think you find this too challenging, hopefully. How about 4y to the 4th minus 64y squared? And by the way, let me just make it a note now. Once you factor out the GCF, then usually whatever is left in parentheses, then you go back and you look at that and ask the question, how many terms are there? And then you try and decide if you can factor that. So for the second one, 4y to the 4th minus 64y squared, I'm going to first factor out the GCF. Now if I look at the coefficients of the numbers, I got a 4 and a 64. I think 4 is in common. So it looks like I can factor out a 4. Then I've got y to the 4th minus y squared. I can factor out a y squared. Now, create parentheses, and now I say what times 4y squared gives 4y to the 4th. Hopefully you all realize it's y squared. And now I have the minus sign here, and now the second term, what times 4y squared equals 64y squared? Actually 16. And now I have factored out the GCF. Now if I was going to continue to finish this problem, I now would take the stuff inside the parentheses and try and factor that. One more last quick example. 3x cubed plus 18x squared. Okay, plus 15x. We're asked to factor this completely, or at least start. First thing you always do, you check for GCF. You check the numbers, then the variables. So here are the numbers, 3, 18, and 15. Hopefully you realize pretty much right away that 3 would be a common factor. Now I check my variables. X cubed, x squared, x. Looks like they all have an x in common. So I'm able to factor out a GCF of 3x, and now for my parentheses, inside the parentheses I'm having three terms. So first, what times 3x equals 3x cubed, well, x squared. I bring down the plus sign. What times 3x equals 18x squared. That would be 6x. And then for the last term, what times 3x equals 15x? It's got to be 5. So this is the GCF. And then I simply factor it out. I'm left with this, and that is something now that you would have to go and factor a three-term polynomial.